Chapter 7, Section 1, Slope-Intercept Form, Master Level. So we're just going to tie together everything that we covered in the previous two videos. So without graphing, quickly determine the slope and coordinates of the y-intercept of each linear function. Okay? So notice that all of these are of the form y equals mx plus b. And in the previous two videos, okay, after graphing, okay, and recognizing some patterns, we noticed that this number here, multiplying the x, that is the slope of our line, and this number here, that tells us where the line crosses the y-axis. So now just looking at the equation, we can tell a lot about the graph itself without actually having to draw anything. So y equals negative 4x plus 9. The slope is negative 4. Okay. Well, the y-intercept is 9, but notice how we have room for an ordered pair. It just means we actually want the full coordinate, not just the y value. Well, of course, x is always 0 at the y-intercept. Always, always, always. There we go. That's simple. Next, we have y equals 9/10 x. We don't have a number here. Okay. Well, there's nothing wrong with imagining there being a plus 0 here. Okay, because normally we wouldn't write that. Well, we can see that the slope is just a rise over run of 9 over 10. But our y-intercept is, well, x is always 0. There. Okay. So if you actually don't have a value here and you were to graph it, you will notice that this line will pass through the origin. So right through the center of your graph. All right. Next, y is equal to 8. Okay. Well, don't panic. Right? So this number is not multiplying the x. Okay? So this cannot be the slope. This actually is the y-intercept. Okay? But what's the slope? Well, there's nothing wrong with imagining there being a plus 0 times x. Okay? Because 0 times x is just 0, so we normally wouldn't write that. All right? Well, this number here multiplying x is 0. And we have seen before what lines look like that have a slope of 0. And if you recall, they are horizontal. So I'll just sketch this one. Okay? So if I have a y-intercept of 0, 8, that would be up here somewhere. So I've gone up 8 units from the origin, but my slope is 0. So therefore this graph is flat. It's horizontal. Okay, so that's what that one would look like. Right. Next one, y equals negative x plus 90. Okay. Well, the number multiplying the x is negative 1. Well, there's an invisible 1 hiding there. Plus 90, so the y-intercept is at x equals 0, y equals 90. I don't think I'd want to plot that. All right, so just to summarize again, so slope-intercept form is an equation that looks like this. Y equals mx plus b. M is the slope. B is the y-intercept. And its location is always at x equals 0 and y equals b. All right, graphing linear equations. Determine the slope and y-intercept of each linear function and then graph. Be sure to plot the y-intercept. All right. So these examples, we get to say goodbye to using tables of values. Okay. We can actually graph the line just by looking at the equation and figuring out what the slope and the y-intercept is. That's all we need to plot what the graph looks like. So we have y equals x plus 5. Remember, you can think of that as an invisible 1 times x. So the slope is 1, and the y-intercept is at x equals 0, y equals 5. Okay, so we can plot this point, okay, because we know that our line passes through it. Okay, but we now need to draw a line passing through this blue dot, but it has to have a slope of 1. Okay? Well, remember that if I have a slope of 1, that's the same as 1 over 1. Okay? And we know that slope is rise over run. Okay? So to move along the line and remain on it, okay, from any point, we can simply go up one space, because this is positive, and this is a positive one, therefore we go to the right one space. We can do it as many times as we want until we have enough dots we can take a ruler and finish it. So from here we go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And I think you can see where the dots are going. So let's plot our line as best we can. Something like that. Okay, there we go. All right, let's do the next one. We have y equals negative 3x plus 2. Do this one in red. So the slope is negative 3. And the y-intercept, that's 2. So the coordinate of it is 0, positive 2. That's all we need to graph the line. So the y-intercept is right here. I know that dot's a bit big, but that's okay. So my slope is negative 3. So remember, a slope of negative 3, you can think of that as negative 3 over 1. That way you can see, here's my rise. Okay, it's negative, therefore I go down 3. And here's my run of 1. So again, I go to the right one space. So I go to my y-intercept, and I go down 3, 1, 2, 3, and to the right 1. I'll do this a couple times. 1, 2, 3 over 1. Down 1, 2, 3, right 1. Okay, and I think you can see where the dots go. Okay. You could actually go the other way too, because remember I explained that the negative sign, we don't usually write it like this, it is the same as 3 over negative 1. Okay, well if we use this one, this says the rise is positive 3, therefore we go up 3. A run of negative 1, this means we go left one space. So let's go back to the y-intercept, but now we go up 3, 1, 2, 3, but now we go left 1. And repeat this process. So you notice that these dots, okay, they still fall along this line that I'm about to draw. So let's fill that in. That's good enough. Don't forget the arrows. Okay, so there's our y-intercept, and it should make sense that this line is going down from left to right. Why is that? We have a negative slope. All right, last example. I'll use purple this time, why not? So we have y equals negative 2/3 x minus 4. Okay, so here the slope is already written as a fraction. It's kind of nice. So the negative sign is written in front. We can keep it there. I can put it in the numerator or the denominator. Doesn't really matter. So I'm just going to, I'll put it in the numerator. Why not? So this is negative 2 over 3. So that's my slope. And here my y-intercept is, careful, it's not 4, it's negative 4. So the coordinate is, again, x is always 0. Y is negative 4. Okay? So I think we can plot it. So that would go right there. All right? And so here, it's a little bit thin. That's better. Okay, so my slope I've written as negative 2 over 3. Okay, so rise over run. So the way I've written it, this says I should go down 2, right 3. Okay, so down 1, 2, right 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. I could also go the other way if I write my slope like this, because this is the same as 2 over negative 3. So now the rise says that I go up 2. The run says now I go left 3. So up 2, left 3. Up 2, left 3. You can see it doesn't matter because all these dots still fall on this imaginary line that I will draw right now. There we go. Okay. And there's my arrows. Okay. Right. So the only thing I'm going to add to these drawings is we know that for the first one, the slope was 1 over 1. Okay, so that means I can draw a little right triangle here, kind of like what we did before when we were counting squares. You can see I have a run of 1 and I have a rise of 1. Here we have a slope of negative 3 over 1. Okay, so I could draw, let's see, right triangle like this. There we go. So here the triangle has a height of 3, but from left to right I'm going down. Okay, and then I have my run of 1. And then here my slope was negative 2 over 3. So I'll just pick a nice point right there. So I was supposed to go down 2 and right 3, so there. So I'll put in these dimensions. This is 3. This is 2. These are just the actual dimensions of the triangle. So I'm not taking into consideration what the sine is. Okay. So there you can actually see the numbers written in.